Welcome to section 9.5, which covers whole skeletal muscle physiology. First, let's discuss what a muscle twitch is. A muscle twitch is going to be your muscle contracting and relaxing in response to a stimulus, which would be our action potential from a nerve. And this can take place in one or more muscle fibers. So we have three different phases in which this takes place. We've got our stimulus that is applied to our muscle fiber, and we have this lag or latent phase. And this is a stimulus of our motor neuron and the start of contraction. Actual contraction phase, though, will be when we have full contraction and tension will increase. After that, we have our relaxation phase where the muscle relaxes. Tension is declining here to 0 and back to its resting point. Now let's talk about the types of muscle contractions that can take place. We have isotonic contraction, and that's when we will have a change in length, but the tension in the muscle will be constant. We have two different types of isotonic contraction. We've got concentric contraction, which is overcoming opposing resistance, and our muscle will shorten. So in this case, we have our biceps brachii. Let's just imagine we have a weight in this hand. So we're overcoming that resistance and the muscle is shortening or contracting. Whereas eccentric contraction, that is going to be when tension is maintained here, but our muscle is lengthening, and we have to have this take place in order for our biceps, the agonist, to contract. The other type of contraction we have is isometric contraction, and that's when we have no change in length, but tension will increase. So for example, if you are holding this weight in your hand, but you are not moving your arm at all. So you're going to feel tension increasing in that muscle, but you're not having that muscle shortening or lengthening at all. You're just holding it in place. You're going to do the same thing if you go over to your wall and you push it with all your might. You're not going to be able to move that wall, but you are creating tension within your muscles and they are not shortening or lengthening. A lot of our postural muscles are going to use this type of contraction. The other thing I want to quickly talk about is muscle tone. This is constant tension by our muscles for long periods of time, and this is due to a small percentage of all motor units contracting out of phase with one another. So some are contracting and then relaxing and vice versa. Here's another great illustration here showing you isotonic contractions. We've got concentric contraction here and eccentric contraction here. So our motor unit, it has to do with a motor neuron. So, coming off of your brain, extending down the spinal cord and going to your muscle. And then that motor neuron is making a connection to muscle fibers, and this can range between 4 or hundreds of muscle fibers, depending on what the muscle is, what it's supposed to be doing. So we know that we have larger muscles that are going to have motor units with lots of muscle fibers, whereas smaller muscles that are going to have more delicate movements will contain motor units with fewer fibers. So what does this all really mean? So I want you to picture a muscle here. We'll draw some striations in here. It means that we can control motor units, or control a muscle rather, by using multiple motor units. So this is I won't write the whole thing, motor unit 1. And then I will have another motor unit coming from over here, branching motor unit 2. And I might even have another one. Let's say this is motor unit 3. And all of these are grouping certain muscle fibers together. So for instance, if you cut through this muscle fiber and you were looking at each of these fascicles, okay, you would see that a nerve fiber is going to each of them. So this belongs all to muscle unit number 3. And we would have some other muscles interspersed in here, right? Because we got to make this a whole muscle. So this would be, whoops, I drew this kind of odd. Muscle unit 1. I'm going to actually extend this back to show you something too. And then lastly, we had muscle unit 2 that we didn't draw in. So you can kind of see muscle unit 2 kind of fills in the rest of the muscle. So we see that there is there's full control of these muscles here. Okay, so the reason I kind of drew these tails back is because what I want you to understand is all of those nerves that we're learning in chapter 10, let's see, let's just use black. All those nerves you're learning from chapter 10, like for instance, let's not use that one. For instance, gracilis is innervated by the obturator nerve, or your semitendinosus is innervated by the sciatic nerve. So these motor units all live within those nerves. So here's one nerve. All of these axons moving on back are bundled together and will create, let's say, this is my radial nerve. And we know radial nerve will supply all of the posterior arm and forearm. So let's say this is one of the heads of the triceps, and what motor units are going to help us do is make sure that this muscle doesn't fatigue, or we can stimulate all of these motor units and get this muscle to completely contract all at once for, let's say, a power weightlifting exercise. Okay. All right. So next we're going to move into stimulus strength and motor unit response. So a lot of people will get a little confused with this all or none law or principle. So all or none, it has to do with nerves and also muscles. So when we say all or none, referring to an action potential, let's say, it means as long as we hit this threshold, and remember that's going to be really discussing voltage. So let's say our threshold stimulus is at -55 millivolts. And down here is where we're normally at, which would be like -70 millivolts. This is our resting membrane potential, right? And we get a stimulus, and sometimes that stimulus is not strong enough to reach our threshold. And so we get none. We don't get a response. We don't get an action potential. So this is called a sub-threshold stimulus. And I put 2 slides kind of together here so this makes a little bit more sense. So our sub-threshold stimulus, let's take a look at all of that. No action potential, no contraction. So we see here, didn't reach threshold. Here, there are no motor units that are excited, so no fibers really working there, and no tension created here. And basically, we're just left down here, no tension again. When we get to our threshold stimulus, okay, we get our action potential, and it's going to send that action potential along the sarcolemma of the muscle and cause contraction to take place. So that would be like number 3. I forgot to circle number 2 for our threshold stimulus there too. So we see that now we've got a motor unit fired. So at our threshold stimulus, that doesn't mean we're getting everything here, all of our muscle fibers. It means that we have at least one motor unit that has contracted muscle fibers. And so we see some strength in here now. We see tension building. And here's our one motor unit response down in here. Okay, let's move on to our next group. So we are getting our action potentials once we hit threshold, right? So how do we determine strength? How do we get a contraction to be stronger? We have to activate more motor units, right? All of these guys. We have to activate the motor units to get more muscle contraction. So we go through something called multiple motor unit summation. And I forgot to kind of touch on something in the previous slide. So I left this blank spot here too, because I want to kind of have this make sense for you. So as far as motor units. So if this is my force of the muscle contracting, and this is time, and we drew out those motor units before, but they disappeared. So anyway, if we use, let's say, motor unit, I don't remember what pink was, motor unit 3 maybe? If you use motor unit 3, we generate this type of force. If we generate or get another motor unit to contract, we get motor unit 2. Maybe it's controlling more muscle fibers there with that motor unit. But if we use both of these in conjunction, let me use a color we didn't use here. We'll use gray. Okay, we are going to be able to maximize force here. So we've activated motor unit 2 here and motor unit 3 together. So we get more force within the muscle. Okay, so let's go back here. So when we get to our multiple motor unit summation, that's kind of what's going on. We're recruiting more motor units in order to get greater strength, greater tension or force within the muscle. Okay, so let's look at these 3 different types. We have our submaximal stimuli. Okay, submaximal stimuli. And basically we are just adding more and more motor units here. So as we recruit more motor units, we get more tension built up within the muscle. Now it isn't until we reach our maximal stimulus that we get that maximal tension. We cannot recruit any more motor units. This means all of our motor units are working. Those muscle fibers are all stimulated and contracting. Whereas our supramaximal stimulus, even though we are getting more stimuli to pick up and use more motor units, we only have the motor units that we're going to have. We can't magically create more motor units. And so we keep this peak tension within our muscle here for our supramaximal stimuli. Okay. So let's talk about tryp first. This is going to be a graded response. So we have our muscle rested, okay, it's relaxed for a long period of time. And then we have low, do I have this on here? I don't. So you're going to have low, there we go. Where was I going? Low frequency stimulation. And so what this results in, if we have this low frequency stimulation, it kind of allows for the next one, the next stimulation that we have. So this is stimulation 1, let's say, or muscle twitch 1, muscle twitch 2, 3rd, 4th, and so on, right? So it's allowing the next contraction to become even stronger. So after a couple contractions, we see that we reach this maximal tension level here. We can't, whoop, where did my screen go? Oh, it got rid of all my writing. Anyway, we can't go any higher than this as far as tension. So why is that? Why are all these contractions equal, and how are we able to increase this after we get relaxation? It's because we have our calcium that would be around our myofibrils here, and within the first few contractions here, the calcium in our sarcoplasm, so surrounding the actin and the myosin, they are going to stick around. And that's why we are more efficient when we contract the next time. Instead of all the calcium going back to the sarcoplasmic reticulum, some of them hang around and we can attach it more to troponin, move tropomyosin out of the way so we can reveal those active sites on our actin filament for the myosin heads to attach there. Okay. So another thing to keep in mind too here is that it's going to take muscle twice as long to relax than it is to contract. So our calcium moves out of the sarcoplasmic reticulum really quickly, but it takes a longer time, more of a slow movement of the calcium to move back in the sarcoplasmic reticulum. That's why they're sticking around, and we can get these next contractions to be to create more tension, more strength within the muscle. Okay, so let's move into tetanus now. Again, this is another type of summation. So it says, as frequency of our action potentials are going to increase, the frequency of contraction increases. That makes sense, right? Action potentials is what is going to cause the muscle to contract in the first place. So what is tetanus? It's going to be a period where we have sustained contraction. So let's focus on this image down here real quick. See how this is sustained and we keep that tension in place? So if we have enough action potentials happening kind of back to back, then we get this complete tetanus. Here's our twitch. This kind of reminds us of our trapé a little bit, right? Except we're not seeing that building of the stronger tension building up. But anyway, we are seeing that we have some relaxation taking place within this muscle here. Whereas if we start seeing in frequency 2, we are more frequently adding action potentials. So instead of this muscle being able to completely relax here, it only partially relaxes. And then so we can kind of build upon that and gain more tension. And then over here, if we add frequency 3, that means we're increasing the frequency even more of our action potentials. And then we move up to even more tension building up on the muscle and partial relaxation. Again, not full relaxation down here, just partially. And then by frequency 4, by frequency 4, we are not allowing any relaxation to take place, and we get complete tetanus where we are able to sustain that contraction. Okay. Oh, and so we call this multiple wave summation. Okay, multiple wave summation. So last thing I want to do before we talk about tension is I kind of want to compare and contrast trapé and tetanus. So, and I'm just going to do this on this slide because I have room here. So we know that both of these are summation, types of summation. So with trapé, we have our stimulus is at its max level. Stimulus at max. So what that means is all of our motor units are activated, stimulated. Whereas our tetanus, our stimulus is just at threshold. And we're just using one motor unit with this. The other difference we're going to see is with trapé, we have low frequency of the action potentials. And with tetanus, we're going to have increased frequency of our action potentials. And last thing is we have in Trop A, we have increased sarcoplasmic calcium. And this is more of a comparison. We are also going to have increased sarcoplasmic calcium in our tetanus as well. Okay, to allow for that summation to take place. So next let's get into tension. Tension is going to be produced by contraction, and this is going to be the force exerted on the load or object to be moved. And in order to create an optimal tension / contraction that takes place, we have to have the sarcomere at rest, so there's an optimal overlap of actin and myosin filaments. So when we look at this illustration to my right, we see muscle length number 1 here. And this muscle is not stretched, and the tension is produced when the muscle is contracting and it's small because there's too much overlap between the actin and our myosin myofilaments. Our myosin myofilaments are running into the Z discs, and the actin myofilaments are interfering with one another. I mean, they're like right at the tip there. And so this reduces the amount of cross bridges that can take place. So we got about 75% of tension that's taking place here. In muscle length number 2, our muscle is optimally stretched, and the tension produced when the muscle contracts is maximal because there's an optimal amount of overlap here of our actin and myosin filaments. So the number of the cross bridges that are going to take place is going to be maximal, so we can reach close to 100% tension. With muscle length number 3, the muscle is stretched severely, and this tension produced when the muscle contracts is going to be small because there's very little overlap here between the actin and myosin filaments, and so fewer cross bridges can form in order to get more tension. So we've got real minimal tension here, I would say like 20%. So I know we've talked extensively about summation and recruitment, but I also wanted to add in the size principle here. While we are recruiting, the smaller motor units, which are represented by these darker pigmented ovals and circles, are going to be recruited first. And then as we move along, we are going to have and recruit larger motor units in order to gain strength and power, whereas we use the smaller motor units more for endurance exercises. And this is the table I just put in as a summary to the types of physiological muscle responses we can have. So you can go ahead and look over this table to help you study.